Hey, grade 12s. So after we've worked out the first derivative using first principles, there'll be about 6 marks allocated to finding the first derivative by using shortcut methods. Okay, not having the 6-line, 7-line long first principles rule. We can rather go straight to the point and use some shortcuts. Just before we go into some examples of finding the first derivative using shortcuts, I just want to say that you cannot have your original function with certain things. You cannot have, let's say, brackets. Okay, so you cannot have a bunch of brackets like we'll see over there and dive into the shortcut. You first have to possibly FOIL out the bracket or time something into the bracket before you can use the shortcut. Secondly, you cannot have roots. Okay, you cannot have x appearing in a square root or a cube root. You first have to get it out by using our exponent rules and rewriting it with x to the power of something. Okay, thirdly, you can't have x or the variable, right, in a denominator of a fraction. Okay, you cannot have a denom, right? You can't have it appearing in the denominator of a fraction. So you first have to get it out from the denominator and put it on the top. Okay, so remember those things there. You're going to have to apply them in most of these questions we'll go through now. Okay, also remember that the notation that they could ask can be slightly different. dy over dx also means find the first derivative. Dx also find the first derivative. Differentiate y blah 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 with respect to x, find the first derivative. Okay, so be on your toes for the different ways they could ask you it, but let's climb into number one. Possibly pause the video, give it your own attempt, and then we'll mark it together. Okay, so first of all, in number one, we cannot climb into finding the first derivative initially. So our first step is to clean up this bracket here. Remember that that bracket all squared means that the bracket is going to be repeating itself, and you're going to have the bracket times together by itself there. Okay, so at this stage, we would FOIL out the bracket before we can use our shortcut. So the f of FOIL means multiply the firsts together. X squared times x squared is x to the power 4. X squared times negative 1 over x squared will result in negative 1. The inners, negative 1 over x squared times x squared is another negative 1. And the last, negative 1 over x squared times negative 1 over x squared is positive 1 over x to the 4. Right. So still, we are not quite ready to use our shortcut. So y would equal to x4. I've got no issue there. Minus 2. Right. And then if I want to get this x out from the denominator, it's going to become plus x to the negative 4. Right. So now we are ready to do dy over dx. As we can see, all the x's are on what? The ground floor, so to speak. We don't have brackets, we don't have roots, we don't have variables in any denominators, so we are ready to rock. Okay, so now we can go and say, right, we can say dy dash if we want to. We can say dy over dx possibly, as that's what the question refers to. And yet, let's use our shortcut now. This 4 will be times by the 1 in the front to give us 4x to the power of. 4 reduces by 1 to give us 3. Remember, the derivative of negative 2 is just going to fall away. There is no derivative that's going to come out of negative 2. It's going to be 0, in other words. Right, this last piece here, the negative 4 is going to multiply it to the front, so negative 4. X to the power of negative 4 is reduced by 1 to give us negative 5. Okay, and there's our derivative, our first derivative of this function over there. There's our answer. Okay, hopefully some of you got that correct. In number 2, you've got the derivative now of that. However, because we've got brackets, because we've got a variable in the denominator, things need to happen first. So I'm just going to write the derivative dx there first. I am now going to do what? In my numerator, I've got the difference of cubes, right? When we have difference of cubes like this, I'm going to have x minus 1 in my first bracket, x squared plus x plus 1 in my second bracket. If I had to times those brackets out, I should get back to x cubed minus 1. So I've correctly factorized that numerator. The denominator is still x minus 1, which you'd notice now can entirely cancel with the bracket at the top. So the derivative that we need to work out for is of x squared plus x plus 1. So now the answer for this would be what? 2x, right, to the power 1 technically, plus, what's the derivative of just an x? Plus 1. Okay, this little 1 over here falls away, it would be 0. Okay, there is our number 2 done. Hopefully some of you got that right as well. Moving to number 3, I'll just slide my page over a little bit here. They give it to you in a bit of a sentence now, and they ask you to differentiate y is equal to x plus 5 over root x with respect to x. Now notice here that there is a binomial at the top. There's two little pieces at the top divided by a monomial at the bottom, right? So we cannot cancel as it stands, but we need to do work before we can actually work out the first derivative. So firstly, if I do not want this root sign, that's going to become x to the power of a half. So x plus 5 divided by x to the power of a half. Now if I want that x to the power of a half to join the numerator, it's going to come to the top as an x to the power negative a half. Remember, the denominator is a positive a half at the bottom, so if it moves to the top, it's going to become x to the power negative of a half. Right, they would then have a bracket form of x plus 5 still. Now when I times this x into the brackets, this is a 1, remember, x to the power of a half, negative a half, times x to the power 1 would give us what? When the bases are the same and you're multiplying, you will add the exponents. So negative a half plus 1 is going to give you x to the power of a half, plus 5 times x to the power negative a half. Right, so now we've got all the x's on the ground floor and we are ready to do our differentiating. Okay, so we want to differentiate y in respect to x. So dy over dx equals, let's use our shortcut. A half will be times to the front, a half x, reduce the half by 1, and you're going to get negative a half. The second term, the negative a half must times with this positive 5 in the front to give us negative 5 over 2 x to the power of what now? My negative a half must reduce by 1 to give me negative 3 over 2. Okay, so while the answer might look quite messy, it is the right answer. Okay, remember with all things, what is the first derivative giving you? A formula that you can use to find the gradient at a point on a curve. Okay, example number 4 of 8 says the following. Find dy over dx if y is equal to all of that. Okay, it's slightly easier. Once again, we're not ready to differentiate just yet. I'm going to write x, or the cube root, the root of x cubed rather, as x to the power 3 over 2. Right? Remember that rule? Minus 5, but now this x I want to come and join the top here next to the 5. So it's going to become x to the negative 1. Do I have any issue or do I need to do anything with plus half pi? No. Half pi is the constant value in our sum here. It could be plus 2 for all we care. It's just the constant value. It's got no x's in it, so it's just going to fall away just now. So now when we work out the first derivative, dy over dx, we use our shortcuts and say 3 over 2x. Now reduce the power by 1. We're going to get to the power of a half. Right? This negative 1 must times by the negative 5 to give me plus 5. X to the power of negative, reduce it by 1, negative 2. Okay, my half pi totally falls away. It's got nothing to derive. So there is my answer for number 4. Okay, moving to number 5. You should be getting the hang of this by now. Number 5, I think, is also quite straightforward. It gives you two brackets here, which before we can climb into the answer, let us multiply the brackets out. So the FOIL says x times 3x is 3x squared. The O and the I of FOIL, x times negative 7 is negative 7x. And then, okay, let's go slowly, not plus, negative 7x, the inners, plus 3x, and minus 7 for the lasts. So before we differentiate, let's just clean this up. 3x squared minus 4x minus 7. Right, now we can work out the derivative. Notice I do not write the dx again. I'm now going to write my first derivative, so I need not repeat that dx. What's the answer? 6x minus 4. Happy? Number 6 just below gives us a similar one to, I think it was number 4. They say the derivative of t now. So the notation, because our variables changed a little bit. Okay, so think carefully. We can't have our variables in the denominator. So once again, like our question earlier, if I want to bring this 6t squared out from the bottom and to the top, it's going to become what? Remember, we are dividing by 6 here, so I could say a sixth, right? And then t to the power of what, right? What am I going to divide? What do I want to change the 2 into? A negative 2, because I've brought it to the numerator. What is left now at the numerator? We had a 1 minus 3t squared. Okay, now let's times that into our brackets, and we're going to get the derivative there. So we're going to have a 6t to the negative 2, because we've just times it by 1. And then we're going to times it by negative 3t squared. So a 6 times 3 is going to be a half. Agree? And then t to the power what? T to the power negative 2 times t to the power 2 is going to give you t to the power of 0, which is going to fall away and just become 1. So there is what we get when we times it in. Now to actually find the derivative, this is going to fall away because it's a constant, so it's just going to give 0. But this term here, when we derive it, is going to be negative 2 over 6, which is 1 over 3, and t to the power negative 3. There is our first derivative in number 6. Number 7, up at the top here, our second last one says, find the first derivative if fx is equal to all that. Okay, slightly easier one possibly. Let me just zoom in for this one. That's zooming out. Okay, let us see. Do we need to change anything just yet in order to do the shortcuts? I don't think so. I think we're ready to rock with the shortcuts. So our first derivative will equal, right? Let's see if you can do this on your own. 4x to the power 1 plus 2x to the power 3. Do you agree with me? What's going to happen with the negative 3? It's a constant, so it's going to fall away. Right, the last question is simply a first derivative question, but maybe worded a little bit differently. It says, if y is equal to x to the power 6 minus 1 all squared, prove that the first derivative, dy over dx, is equal to that if x is greater than 1. Okay, so it's a bit more confusing than the others, and it all lies with finding the first derivative over there. So let us think, if we need to get rid of that bracket, that would make y equal to x to the 6 minus 1 and x to the 6 minus 1. Let us multiply this out. We're going to get x to the power of, right, x to the 6 times x to the 6 is x to the 12, minus x to the 6, minus x to the 6, and plus 1, right? We're now going to have x to the 12 minus 2 x to the 6's plus 1. Okay, at this stage we would find our first derivative, so dy over dx is equal to, first derivative of x to the 12 will be 12x to the 11, minus first derivative of negative 2x squared is negative 12x to the 5. And plus 1 is going to fall away because the derivative of a constant is 0. At this stage, let's keep our eye on what we want our answer to end up looking like. So what would we do? We could take out a highest common factor at this stage. So what is common between these two terms? 12 is common, and x to the power 5 is common. What is left then if I've taken out an x to the 5? X to the 6 is left, and I've taken out this whole thing, so minus 1. Right? We're not quite where we want to be, so let's look carefully. Our original question said that y is equal to x to the 6 minus 1 all squared. So if our answer at this stage has got an x to the 6 minus 1 without the square, what do you think I could replace the x to the 6 minus 1 with? Well, I can't replace it with a y because it would need to have a square there to fully replace it with a y. However, I can replace it with a root of y, because if I had to root the right side over there, I would get x to the 6 minus 1. Therefore, I must root the left side to give me root y. Okay, and we have successfully completed the question, and we've made it equal what it wanted us to equal. Okay, so I hope those 8 questions on how to find the first derivative using shortcuts assist you, worth about 6 marks in your exams, and they're marks that you can definitely get. Okay, in the next video, I'll be moving on to cubic graphs.